Today we're going to be looking at this force table. At the moment it's got two masses suspended from either side and they're equal in mass. And when you look from above you can see that this ring here is freely suspended and is not contacting this pin in the middle. Now what would happen if I were to add a mass to one of these sides? If I add a mass to one of these sides, it's going to start to move towards that side. So let's try it. And now when I let go, you'll see that it's moved over here. And the ring on top is now firmly pressed against the pin in the middle. And if I lift this off, you would see that it would start to move towards this side. So why is that? Well, let's go back to the original conditions. Here you can see again the circle is not touching the pin. At this point we're going to consider the two forces that are acting on this ring. We've got the force in this string pulling this way, and we've got the force in this string pulling this way. Because our masses are equal on both sides, those forces are the same. So we consider that this system here is in equilibrium. The resultant force is 0. So what do I mean by the resultant force? Well, the resultant force is when we consider all of the forces acting on an object and turn it into one single force. In this case, let's take the force that's acting this way and we'll call it x newtons. And the force going this way will give a size of y newtons. Because they're the same, x equals y, the resultant force of all of the forces acting in this direction minus all of the forces acting in that direction gives us 0 newtons. And because the forces acting on this ring are therefore 0, it will stay where it is. If we increase the force on one of those sides by adding on a mass, we're now making this force larger. In this example, we'll say it's x plus 1 newtons. Therefore, when we work out the difference between the forces, we find out that there's an increase of 1 newton to the left, and therefore the ring will move this way. Alternatively, we could remove the mass from this side, putting it back into equilibrium, and move the mass over to this side. By increasing the force on this side, will cause the resultant force to shift towards the right, and therefore the system will move in this direction. Like so. This is quite a simple system, and we're only looking in one dimension, across. What would happen if we started to look in 2 dimensions? Well, let's find out.